Bottom of the page, star, chemical elements, symbols, and formulas. All right, so we're going to talk broadly about the periodic table now, and there's almost 120 or so elements on the periodic table nowadays. Some you know, oxygen, iron, gold. Some you've never even heard of, like rhenium, molybdenum, niobium, californium. There's some really weird ones. Now, the top of this page of notes, it starts out by saying there are 4 elements of those 120 or so elements on the periodic table. 4 elements are essential for life, and you've no doubt heard of these. CHON, carbon, hydrogen, oxygen, and nitrogen. All right? So the second bullet point there says all elements are represented by chemical symbols in the periodic table. Sometimes it's just 1 letter, sometimes it's 2 letters. If it's 2 letters, the first one is capitalized, second one is not. So chemical symbols made up of 1 or 2 letters, and the first letter is capitalized, the second is not. All right? So yet another example problem. It says, what's the element's chemical symbol? And we'll use the periodic table. You should have one inside your textbook. You might have one. You can always find one on Google Images. So what's the element's chemical symbol? Use the periodic table. A, uranium is U. Titanium is Ti. Tungsten is W. You might be wondering why tungsten is W. The Latin name for tungsten is wolfram. Example, what elements do the following symbols represent? So now we're going to go the other way. We're given the symbols. What's the name? Well, Na, Ca, Pd, K, Sr, and Sn. Na is sodium, Ca is calcium, Pd is palladium, K is potassium, Sr, strontium, Sn is tin. All right, now more on atomic symbols, symbols on the periodic table. It says symbols, which represent elements on the periodic table, are combined to make chemical formulas. So a chemical formula is going to represent a chemical compound. So it said what it's saying here is that you take a symbol on the periodic table and you combine it with another symbol on the periodic table, and you can make a chemical compound, and that chemical compound has what's known as a chemical formula. For example, if I take Ca, calcium, and O, oxygen, and I put it together and make CaO, that's calcium oxide. Calcium oxide is my chemical compound. CaO is the chemical formula. All right, so let's do an example. Which elements are in each formula, and how many are there of each? So really, you just have to have eyes to do this. So for NH3, there's 1 N and 3 H's. For B, NaHCO3, there's 1 Na, 1 H, 1 C, and 3 O's. C8H18, well, that's 8 carbons and 18 hydrogens, right? So what you're seeing there in A, B, C, D, and E, the first thing I'm writing, like NH3, NaHCO3, C8H18, and then E is CaBr2, those are chemical formulas, and they represent chemical compounds. All right, so further delving into the periodic table here, we're going to break it down into 3 main sections. We have number 1 are the metals. Metals are the most abundant type of element on the periodic table. These guys are malleable, which means you can hammer them into thin sheets. You can kind of flatten them out like aluminum foil. Ductile means it can be drawn or pulled into a fine wire. Lustrous means they're shiny. In general, metals conduct electricity. Most of them are solids, and they're found on the left-hand side of the staircase on the periodic table. So as far as the periodic table is concerned from a mental viewpoint, metals are in the middle and off to the left. And there's like 90 plus, more than 90 plus of the roughly 120 elements are metals. Most of the elements on the periodic table are metals. Number 2, there are 17 of them, and they are nonmetals. Nonmetals are poor conductors of electricity, right? The opposite of metals. They're found on the right-hand side of the periodic table, kind of above the staircase. The staircase is where we're going to separate metals and nonmetals. So that staircase, what's separating metals from nonmetals, all the elements along that staircase are going to be the metalloids. And there are 7 of them. And you would want to know all 7 of these metalloids. So these used to be called semi-metals back in the day. But as you might expect, metalloids being on that staircase, that the boundary between metals and nonmetals, metalloids share properties of both metals and nonmetals. As I've mentioned several times, but now we have it written down in our notes, it says, found in a staircase manner between metals and nonmetals on the periodic table. The metalloids are boron, silicon, germanium, arsenic, antimony, antimony is Sb, Te is tellurium, and At is astatine. Periodic table. So we're just going to make a few bullet points on some of the different groups of the periodic table today. Then we're going to go into something called electronic structure of atoms. So the periodic table at the top says, remember metals, nonmetals, and metalloids? We talked about those and where they were located in the periodic table. Well, periods are horizontal rows. There's 7 periods across the periodic table. And in groups, there are 18 vertical groups. All right? Now, the actinides and the lactonides are down at the very bottom of the periodic table, separated. They don't have a group. So, some important groups are group 1, the alkali metals. These are shiny, soft, very reactive, and they react with air and water. So when they're stored, they're actually stored in oil because they're so reactive. Group 2 are the alkaline-earth metals. These guys are also shiny, but less so. And then they're also less reactive than the group 1 metals. They do react with water, but they don't react with air. So the alkaline-earth metals are things like magnesium and calcium. Alkali metals are things like lithium, potassium, sodium, group 1. So group 1 and group 2 are so reactive that they're not found in their pure states in nature. They're usually found in compounds. Group 17 are called the halogens. That's the far right column, not all the way. It's the second to the last far right column. Halogens. These are things like chlorine, fluorine, bromine, iodine. These guys are colorful, corrosive nonmetals, usually found in combination with other elements. Then group 18, very far right, noble gases. Noble gases used to be called inert gases because they're very unreactive. They like to be by themselves. But they're very colorful. You find them in some of our lights, things like xenon, and other ones are krypton, helium, argon, etc. All right. Now